Ever wondered how the game of chess and the field of physics might be interconnected? Well, it's not as abstract a concept as you might think. In fact, the two share a surprising amount of common ground. Consider the chessboard, a flat, two-dimensional plane. In physics, space-time, the mind-boggling four-dimensional continuum where all events occur, can be considered as an infinitely complex chessboard. The pieces on our board represent particles in the universe, each moving according to their own set of rules, just like rooks, bishops, and knights follow specific patterns of movement. Imagine a pawn advancing forward on the chessboard. It moves in a straight line, not deviating from its path unless it's capturing an opponent. This mirrors a fundamental principle in physics. An object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Take another piece, the bishop. It moves diagonally across the board, never straying from its color. This can be compared to the principle of conservation of momentum in physics. Just as the bishop maintains its path and color, momentum remains constant in a closed system unless an external force acts upon it. Now think about the knight with its unique L-shaped move. It's the only piece that can jump over others, seemingly defying the rules of the board. This can be likened to quantum particles in physics, which can occasionally jump from one energy level to another without passing through the space in between, a phenomenon known as quantum leap. A game of chess is not just about the positions of the pieces, but also about the strategy and potential future moves. This is reminiscent of the Heisenberg's uncertainty principle in quantum mechanics, where we can know either the position or the velocity of a particle, but not both at the same time. Just as in chess, where planning for the future inherently involves some uncertainty, so too in physics we must embrace a degree of uncertainty in our understanding of the universe. And what about the black and white squares on the chessboard? They can represent the dual nature of light in physics, which behaves both as particles and as waves. Just as a chess piece can only occupy one square at a time, light can only be observed as either a particle or a wave, but not both simultaneously. In conclusion, chess and physics both involve navigating complex systems with their own sets of rules. Whether it's moving pieces on a board or understanding the behavior of particles in the universe, these two fields challenge us to think strategically, embrace uncertainty, and constantly reassess our understanding of the world. So the next time you sit down for a game of chess, remember, you're not just playing a game, you're also engaging with some of the fundamental principles of physics.